Hello everyone, this is Batul and me and my team, April, Shannon, Andrew, Samuel and Quentin, would like to present the Boulder County post-fire mitigation response to the Calwood fire. The goal of this project is to make improvements to mitigate future debris flows and higher water flows through Deer Canyon to protect existing infrastructure. We also want to ensure the continuation of water supply to the surrounding residents. The Calwood fire was sparked on October 17th and extinguished on November 14th of last year. As you can see in this map that shows the 10,106 acres that the Calwood fire burned above Gear Canyon within Boulder County. The fire event put the Gear watershed and transportation infrastructure in jeopardy.
During our site visit, Mike Thomas and Charla Benjamin, two key engineers with Boulder County, identified primary considerations for our design. The first consideration was duration, so we created a design with an intended 5 to 7 year life, so structures can be removed once soils and vegetation are recovered. Fire burn can cause soils to become impervious, which causes water to run off the soil rather than soak in, and this creates a larger and more dangerous flow of rainfall and debris. The second main consideration was access. There were two parts of access we considered, which were the access of installing the structures, since there are no roads or load-bearing soils capable of supporting heavy equipment or machinery, and the access of clearing and maintaining the structures while in place. We needed to make sure to incorporate this consideration so that one or two people will be able to safely access and maintain the structures. Within the Calwood fire burn, we focused on the Gear Canyon area, which is in the southeast of the burn perimeter. Per the burned area emergency response teams and our own further analysis of the soil burn severity and soil type, areas of expected high debris flows are indicated by the red lines on the map on the top left. Using this map, we identified 3 major draws and 3 major locations that will experience the highest level of debris flows. The map on the bottom right shows our 3 main points of interest. In order to prevent erosion and rainfall events from causing severe damage to the trail and communities surrounding this area.
To design improvements in the post-fire environment, we needed to calculate the discharge that would come out of the major draws and catchment areas. In the upper draws at point of interest 1 and 2, we expect an increase of almost 2 times the original flow due to the fire damage. The increased amount of water in the channels is expected to develop into supercritical flows. Supercritical flow causes scouring and hydraulic jumps that lead to erosion of sediment and debris to be carried down the channels, onto the roads, and into the creek. The lower basins at point of interest 3 have a similar change in the post-fire environment, with around a 2 times increase in discharge expected as well. For the debris we expect to be carried in the draws, we calculated rocks up to 4 to 6 inches to be moved by the increased flows. For the amount of sediment and erosion expected, we created this plot of probabilities of sediment ton per acre that would show the chances of the amount of debris for the first 5 years of the post-fire environment. At the 30% probability, that tonnage of sediment is approximately 11 tons per acre in the first year, 5 in the second year, 1 in the third year, and less than 1 in the fourth year.
Across the 3 different point of interests, we have designed 6 different structures to mitigate the effects of erosion and flooding caused from storm events. The green dots represent the debris deflectors and will be placed along each draw. They are represented by that picture with a triangular shaped rack system. The beige dots represent the debris racks, which will be placed at each culverts. These ensure that small to medium-sized debris items do not clog and enter the culverts. The blue dot will be the armor drainage crossing, placed at point of interest 2. The red dot will be the reinforced concrete pipe culverts and headwalls, placed at point of interest 1. The yellow dot represents the flood barrier bags, placed at point of interest 3, and the white dot represents the grouted riprap, placed at point of interest 3 as well.
A defining recommendation at point of interest 1 is the implementation of 2 36-inch reinforced concrete pipes that will run across both ends of the road leading from the draw and into the channel. The fire ended up burning away the existing plastic culverts, and these tunnels-like structures will allow water to pass through them between 2 points. Profile view of such a structure can be seen in the image to the top left. At point of interest 2, an armored drainage crossing is recommended. Different to the culvert previously discussed, it will allow water to run across the hiking trail instead of underneath, and it will allow water to go from the draw and into the channel. An example of such a structure can be seen on the bottom left. At point of interest 3, grouted riprap along the draws is recommended in order to slow down speeds of water flows and debris running down. Currently, there is riprap along the channel that is not anchored with grout. The rocks will become part of the debris flows. An example of what this type of structure looks like can be seen on the image to the bottom left. Flood barrier bags are also recommended to be placed across the double-barrel culverts, which can be seen on the images to the right. These will keep water flows from running across the paved roadway in the event that the culvert cannot take exceeding water flows.
As you can see, these are the costs that we've calculated for each of the 6 different parts of our design. The 2 most expensive parts of our design are the 2 culverts and the 4 debris deflectors. Much of the work done on site, in this case the debris deflectors and racks, will have to be welded together on site as they cannot be transported ahead of time. Though most of the work is going to be in materials and labor, this is mainly due to the poor access of the location, as much of the equipment will have to be small scale. And thank you for watching.